Hello everyone. My name is S.K. Karthikeyan, Associate Professor, Kongunadu College of Engineering and Technology. Today we are going to see a few topics on kinematics of machinery subject. So in the third unit, that is kinematics of cam, we are going to see the introduction for cams and followers. So cam is nothing but a device that convert rotary motion into reciprocating motion. You see the slide, there is one animation that shows a follower that goes on suspended on the cam is the dark blue in shape, dark blue in color you have seen in the picture, animation picture. So that going to rotate in the shaft, over which a follower is suspended having a point of contact in that. So the cam going to rotate out here, that having a oval shape. Due to that the follower goes up and down. So finally we have achieved the conversion of rotary motion into reciprocating motion. So mostly this kind of arrangement used in the inlet and exhaust valve opening of an IC engine. You have seen the thing in the animation. You have seen there is an arrangement of inlet and exhaust valve. The camshaft going to rotate about the by means of a timing gear. The cam that pushes the valve towards up and down. So by that the fuel can entered or moved out from burn gases are moved out from the burning areas. Okay. Next, the classifications of cam mechanism. So first one is based on the modes of input or output motion. We have three classifications. First one is rotating cam translating follower. The second one is rotating cam oscillating follower. Then the third one is translating cam translating follower. Coming to the first classification, that is first example, rotating cam and translating follower. You have seen in the animation there is one cam that rotated in the camshaft due to the unique shape in the curvature, that is a shape profile. The follower going to move up and down. So the rotary motion of a cam is converted into translating follower, translating that moves up and down. So the cam here is going to rotate, the follower is moving linear, that is up and down. So that's why we have the name rotating cam translating follower. The second one is rotating cam oscillating follower. So you have seen in the animation, that is the follower having a roller end that is suspended on the cam. The cam rotated about its axis. Due to the unique shape in the profile, the follower going to oscillate about its support. So this is rotating cam oscillating. Oscillating means rockering, that is moving up and down about the pivoted end, like it's a zigzag movement. So we name it as oscillating. That motion is oscillation or rockering, everything. So rotating cam oscillating follower. The next one is translating cam translating follower. Translation means movement in any one direction, it may be up and down, it may be in linear wise, left right. That is we name it as translating. Here you can see in the diagram, here the cam is moving from left to right. The follower that is suspended on the cam profile is moves up and down. So both the thing having a motion. The first one is cam achieve left to right motion. The translating the follower achieves up and down motion. So both are translation. Then the next one is classification of followers according to the shape of the follower. So the first one is knife edge follower, then second roller, then third flat faced, then fourth one is spherical faced follower. So you have all the thing in the diagram. You see the first diagram is knife edge follower. The follower edge is look like a sharp point, that is look like a knife. So that's why we have the name knife edge follower. The second one is a roller type of end. it's a ball type of end having a contact with the cam. So that's why the name roller follower. The third one is flat or mushroom type. Flat faced means it's a disc like structure there that having a contact with the cam. So when the cam rotated means the disc going to move up and down. So the other name for this flat faced is disc type, mushroom type, or a flat faced follower. Then the last one is spherical faced follower. So that having a half circle unique shape of a cam, and the link of the follower is pivoted horizontally. So when the cam rotated means it's going to attain a oscillation motion in the arrangement. So this is the example for knife edge follower. Already we have seen this kind of animation. A point of contact having is suspended on the cam profile. So when the cam rotated means the follower is going to move up and down in its position. Then second one is roller follower. Here the follower end having a roller or ball like structure. So when the cam rotated means the follower suspended on the profile of the cam going to move up and down. Then the third one, flat faced or disc type or mushroom type. So you have seen the diagram, there is a disc type of arrangement having a contact with the cam profile. So when the cam rotated means this disc like structure moves up and down. So this is the animation for that. You can see the disc going to move up and down. Then the last one is already we have seen there is a pivoted lever having a half circle cam profile that that follower is suspended on the cam surface. So when the cam rotated means the follower is going to move up and down, that is oscillated up and down. Then coming to the next one is the classification according to the path of motion of the follower. There are two main classification, that is radial follower and offset follower. Normally we are mentioning it as radial method, offset method. This is the arrangement for a radial follower method. You see the axis of the cam and the axis of the follower both are lying in a same point, same line. That is, when the motion of the follower is along an axis passing through the center of the cam, it is known as radial followers. So all the four diagrams having the axis, that is cam axis passing through the center of the follower. Okay, next one is offset method, offset follower method. That is, you have seen the axis of the follower that is just far away from the center of the cam, that is shifted like arrangement. So this arrangement is known as offset follower. When the motion of the follower is along an axis away from the axis of the cam center, it is called offset follower. Then the classification of cams. First one is wedge or flat cam. Then second one is spiral cam. Then radial or disc cam. Then cylindrical cam. Then translating cam and spiral cam. Finally end cam. Now coming to the shape arrangement. So these are all the pictures for the wedge or flat cams. You see the wedge like structure of the cam having the motion in left to right, the suspended follower, that is knife edge follower or roller, anything that going to move up and down in the picture. The second one is spiral. Spiral cam, you have seen the cam having a grooved circular type of a spiral type of groove. In that the follower is pointed or fixed as a pin gear. So when the cam rotated means the spiral groove going to expand. So the follower going to follow the spiral expansion. So it going to achieve the motion in left to right. Then the next one is radial or disc cam. This is already we have seen there is a cam, there is a unique profile cam is going to rotate in the camshaft. The suspended follower is going to move up and down. Then the next one is cylindrical cam. So you can see in the picture of a arrangement, that is a cylinder like cam having a grooved portion. The groove is look like a zigzag. Okay. So the follower which is suspended in the groove going to move left right. So when the cylindrical cam rotated up the axis means the follower going to move left right or right left. The next diagram is oscillating type of follower. There is a follower which is pivoted at the top, and the end is ball-like end is suspended on the cylindrical groove. So when the shaft, that is cylinder, going to rotate, that means about its center. When it is going to rotate, means the cam going to follow the groove. So that going to attain a zigzag arrangement. Then the next one is translating cam. Translation means moving left right or right left. So here you can see the cam having a groove which is having unique path. So when the cam is fixed in the groove means when the cam moving left to right means the follower going to up and down. So likewise the motion going to attained, that is translation motion of cam going to give the translation motion to the follower. Then the last one is spherical. There is spherical cam. Here you have a unique shape of a ball, that is spherical ball having a groove in the top. The follower is suspended in the groove. So there is a roller type of ball is suspended in the groove. When the cam going to rotate, that means the follower going to follow the groove. So it going to attain a oscillation because the other end of the follower is pivoted. Then this one is globoidal. Globoidal having a two type of globoidal there. One is concave, another one is convex. Both are mentioned in the slides. You can see the first one is having a groove in the over its surface. When the cam going to rotate, and the follower suspended in the groove going to oscillate. The second thing also having the same type, that is the groove is made on the cylindrical surface. The follower is suspended in the groove. The other end of the follower is pivoted at the top. So when the arrangement going to rotate, the cam arrangement going to rotate means the follower follow the groove and it going to attain the oscillation. Then coming to the last one, end cam. It is similar like a cylindrical cam, but the arrangement having some unique point of contact. You have seen in the picture that a cam which having a unique periphery in the top. So a roller follower is suspended on the over that periphery. When the cam rotated vertically means the follower going to move up and down. So these are all the types of cam and types of follower in the cam arrangement. So that's all today. I think you have understand everything, and thank you all.